So let's talk about how Java works with different hardware. So here's three examples. There's many examples. We have x86 processors, which are typically running Windows in most cases. If you have a Windows computer, it's probably running an x86 compatible processor. There were some chips made by Motorola called 6800s a long time ago that were very popular. There are ARM processors that you might find in your cell phone, in an Android device or an Apple device. And these three hardware platforms run programs that are not compatible with each other. Each of these platforms have their own machine language. So it's a language that that particular processor understands. And the language for all of them is in ones and zeros. So you'll notice that instructions for the x86 are a lot longer than the instructions for the 6800. The 6800 is a very old CPU, and that's why it has much simpler instructions. And so we call this machine code. And these three examples actually show how to add two integers using the different processors. The way you get this machine code is by writing a program in assembly language. Okay, so we have a program called an assembler, which will take code that is basically human readable and convert it into these ones and zeros, which really only a computer can understand. So we have assembly code, and you would type assembly code in a text file just like the way we type Java code, and a program called an assembler would convert that into machine code. So assembly is very difficult to understand. It's very long. It takes a lot of instructions to do very simple tasks. So we have the C++ language. In C++, we can write a program in C++, and using different compilers, we can have the program run on different hardware platforms. So for example, to use the previous example, if we want to add two numbers together, that code in C++ looks the same, but we use different compilers to get different machine code output from the compiler to run on different hardware platforms. So now let's compare the Java language. So the Java language also produces machine code, but it does this via a Java virtual machine. So the interesting thing about the Java language is that you compile your Java code into what's called Java Byte code. And that Java Byte code runs on a Java virtual machine, which is just a program that is specific to the hardware. So an x86 has its own kind of own Java virtual machine. The ARM processor has its own Java virtual machine. But they all run the same Java Byte code. The difference is the machine code that they produce. They still produce machine code specific to their processor. So essentially what you have is one program in Java being able to run on all three platforms. Machine language. A central processing unit understands instructions written in binary. This 32-bit instruction here adds two values. This is called machine language. The instruction is broken down into different parts so that you can understand it, but really only the CPU can understand it. So to write in machine language, we're going to use assembly language. Machine language is not easy for people to read. Rather than writing in binary, a programmer could write ADDI for the opcode 001 and that number, comma $R1 for the first address of 1 for a more readable instruction. So basically you're saying add two numbers in what are called registers. They're kind of like variables. However, CPU only has a very small number of registers that it can use, and it's saying what quantity to add and where to store the result. So this is an example of an instruction in machine language. Once the programmer is finished writing a program in assembly, she could convert the program into machine code so that it could be run by a CPU. This conversion program is called a compiler. Compilers translate between languages, so the human readable and the machine readable. Higher level languages. Writing programs in assembly is still difficult because it takes many instructions to write a simple program. This is why assembly is considered a low-level language. Python, by comparison, is a high-level language. So in Python, this is hello world. If you wanted to do the same in assembly, it's several lines. A language such as C removes some of the details from assembly source code, making it easier for programmers. So when we hide these extra details, it's known as abstraction. So here's the program in C, very short as well. And it's short because a lot of the details are abstracted away. Different CPUs can be grouped by the machine language that they follow. The CPUs found in cell phones typically have an ARM architecture. CPUs from Intel or AMD found in your computer have an x86 architecture, which is why they can run the same software. So Java, because different architectures have different machine code languages, different compilers are needed for CPUs that use different architectures. C and C++ programs are compiled or translated into machine code for a particular CPU and then executed. Java programs are compiled into bytecode. To execute the bytecode, another program is needed called the Java Virtual Machine, or JVM for short. The JVM compiles the bytecode to machine code and executes it as the Java program runs. The JVM is called an interpreter rather than a compiler. This is because it's interpreting the code rather than compiling it permanently. Different CPUs have different versions of the JVM because they must convert bytecode to different types of machine code. So one advantage of a Java program is that the bytecode can be executed on any platform. And here's an example of what a graphical user interface looks like on different platforms. So it's the same program, but the style of it looks a little bit different.